At the very least, it's audio, right? Okay. So I just want to do a little couple things, and I got a handout that's going to lead us into a certain idea that's going to be huge almost the entire semester. What have we got so far? We got mean. What symbol do we use for mean? Yeah, what's X bar? Be specific. Of a sample. What's the one for population? The little U that's got an extra leg. It's the French cow, right? U? I think the book uses a big ass N, but that's just dumb. So we're not going to use a big ass N. N just means the number of things you're looking at. So if you're looking at a population, it still is N. So the only difference between two of the symbols represent if you're looking at a population or a sample, and that is huge. So I want a shortcut to know which one I'm looking at, so we use the symbols to tell us which one are we looking at. I like it. Then we had the idea of the median, which really isn't, the book's got a bit of a formula for it, but it's just finding what percentile is the median. What's the median mean? It's the halfway point, so what percentile is it? 50th, right? What's the symbol we use for the median?
The silly hat.
Sure, I like it. Silly hats only. Kick ass. Then we had the mode. Well, let's see. Yeah, there. Mode, which is just the one that occurs the most. And there's one more I want to tell you about. It's called the mid-range. Who remembers what the range was?
Kind of.
High minus low, right? The range is a number. It's the high minus low. So what should the mid-range be?
Half of that? The range, half of the range.
So is half of the range added on, so you can just say the average of the high and low. So the mid-range would be high plus low divided by 2, the middle of the range. These are basically all four. These are all the ways to figure out a center of data. There isn't a single idea of center, because we saw situations where one of these made more sense, right? And sometimes this makes more sense because this is the only one that works for qualitative data. I like it. And sometimes this guy is useful. Not very often, but for a little bit. Okay. You guys all semi with me? Maybe. Okay. There's section 2.6. I'm not going to say too much about, because you should be able to read it and see what it's talking about. It talks about the skew, how distributions might look. So a normal curve is an example of what kind of distribution? Who's done that? Symmetric. Boogie woogie. So a normal curve is symmetric. Is this curve symmetric?
No.
Of course it is.
Oh, yes.
What does symmetry mean? There's a mirror somewhere, right? And here the mirror's there, right? So symmetric just means it's kind of, you can cut it in half and it folds on top of itself. Right? It could be roughly symmetric, it could be perfectly symmetric. If you've done section 2.6 homework, you saw what I mean, or you will see what I mean when you do it.
Would that be bimodal, the second one?
Yeah, good. That would be bimodal. Kick ass. Because there's two things that occur the most. All right, how we all doing? We all good?
So symmetric is basically even.
I know what you mean. What's really funny is, in algebra, there's something called even symmetry, which is what this really is. It's symmetric
Okay.
about a midpoint, like you put a mirror somewhere.
Mm-hmm.
I love it. Kick ass. Kick ass. Okay. Then you got something called skewed. Get in there. You could either skew to the right or skew to the left. And we normally consider it from a normal curve. So which way does it look like somebody's pulled on this normal curve to make it look like this?
Down.
Which side did somebody pull on?
Right or left?
The one that makes an L is left. So that's right. And now I'm not doing that to be mean to you. I have to do this shit, right? Yeah, this is the thing. If you have too much math in your head, you forget left and right. So I'm driving, I got to do this, and somebody's giving me directions. Turn left. L, that way. Okay. What am I talking about? I don't know anymore. If I took this, which side would I pull on to make it look like that? I think of it like a mound of taffy. Do you guys know taffy?
Mm-hmm.
Taffy. Are you guys with me? I love that everybody's like, what the shit is this guy on? If I pull on this side, it looks like that, right?
Yeah.
So that is skewed right. So could you draw one that's skewed left? Of course you could. It just has a big old tail going the other way. Later this semester, we will see something that looks like this. I will call it the Jabba the Hutt distribution, because that's what it looks like, right? Big old tail. If you don't know Jabba the Hutt, I don't know what to make of you. Missed out on a good thing. If you saw the prequels and never the originals, oh my god. Anyway, sorry. I'm gonna start with this. So in a symmetric distribution, in a normal distribution, the mean equals the median equals the mode. But it obviously, for any symmetric distribution, that doesn't have to happen. You guys see that?
No.
I like it. But a normal curve, not paranormal, I love that. Normal curve, the mode is equal to the mean is equal to the median. It's nice.
But
So a few of the questions in 2.6 deals with that connection.
But if it's like the second one.
Good. If it's not, this is normal. A normal curve is just one type of symmetric curve. If it was this, is the mode equal to the mean? What's the mean in this? Where is it? Roughly where the dotted line is, right? Isn't that where the mean is? If you average everything together, it's going to be right in the middle. Is that where the mode is? Who told me earlier it was bimodal? There's two modes. One's there and one's there. So ain't no way that sucker is
Right.
mean equal mode, right? Okay, maybe. You guys, stop for a second. You guys. Oh man, I don't want to play poker against any of you. You got this face like that. Yeah. All right. Let me think. What else was in that section? Anything else interesting? No. Okay. So that dealt with symmetry. It dealt with skewness. Section 2.6. Section 2.6 should be fairly quick. Tomorrow I will wear my show your work shirt, but it doesn't only apply on days that I wear it, right? You must show your work. Okay, so let's get to the meat of today. I've got a handout, believe it or not. Do I? I do. By the way, as soon as we're done with chapter 2, whatever time is left is going to be devoted to review. I've got the answer key for the practice test that I'll give out later. All right. So what I want you to do, it might be a good idea to get in groups of 4, right? In fact, oh, what the hell, I'll push it. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 30, 32, 34, 36, 37. Damn, it's like one.
One off.
Almost. All right. So, let me give this out. Don't work on this yet. Oh my gosh.
Oh, I gotta go to work tonight. I don't want to. Guess I'll do my homework at night.